I think. That was quick, just to open and close OBS. It's weird I didn't pick it up last time. Software is funny like that, don't you know? Alright, so anyway, we had our deck class. This was mostly done. Again, we had to loop through, but we didn't have all the enums. And then we had started talking about poker hand, what this might look like. We could sort it, and then use these rank enums. And we could have win, lose, or draw based on the hand rank that I got. And then we had to figure out how we tie-break all these things after we're done. Right? So we're getting close. We're getting close. So let's see if we can wrap this up and then add the game portion where we actually play the game. Just got to get some hydration in here. All right, let's see. So let's go back to card. We'll finish up card first. So we need to make another enum for face. Right, and face was like 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope, that should have been 9. 10, Jack, Queen, King, and Ace. And let me bump that down a little bit because that's getting a little bit long there. I don't want to scroll over too far. Okay, so there's our enum for face. And then our copy constructor. Right, oh, here's our suit and get suit. And then we need a private face, face. And then we need a get face. And I don't want to write the code, so I'm going to insert here. Now that one's like super easy to write, but you know, I can do a couple clicks here too. Okay, so we got a get face, we got a get suit, and then we need another constructor card that takes a suit and a face. Now let's do face and suit. Because we usually say like 2 of hearts, right? Is how you would usually do it. And then this face is the face you give me. And this suit is the suit you give me. So for our copy constructor, we pretty much do the same thing here, but not exactly. So this face is the card face, and this suit is the card suit. And really, this is redundant at that point. Card. So if you give me another card, I'm going to copy its face, and I'm going to copy its suit. I'm going to copy its enum values. Okay, so now card is done. Oh, compare to. No, it is not done. So now we need to figure out how we sort these things. Right, and we said, well, really, only it matters is the face value. So we're going to return my face.ordinal minus the other.face.ordinal. Right, because if we have the same ordinal for our face value, if we're both jacks, right, we're going to return 0, and 0 means we're equivalent. We're equal to when we compare. If my face value is greater, if I'm a jack and they're a 9, my ordinal is going to be higher. And they're going to be lower, so I'm going to get a positive number, which means I'm bigger than, which is what we're supposed to get, positive number. And then if I'm less than, if I'm a 7 and they're a jack, I'm going to be less than, I'm going to be a negative number, which is correct. All we need to do is compare those ordinals of the faces. Okay? So then deck here needs to loop through all those enums, right? So we're going to say for card dot, nope. Card dot face colon card dot face dot values. Right, we can loop through all the values in a given card, in a given card face enum, and then we're going to do it again. We're going to do an inner loop. We're going to loop through every suit then. Suit in card dot suit dot values. Right? We're going to create a new card. We're going to take our cards array list. We're going to add a new card given the face and the suit. Okay, so every time we make a new deck, we call the constructor. It's going to create all 52 cards and make a new random. Then when we want to get a random card, we pick the random index between 0 and up to the size, and we remove it and give it back. That makes sense for deck? So every time we want to do another hand, we can just make another instance of deck. Oh, my bit rate's going crazy right now. Okay, so deck looks pretty good. Card looks okay. Now poker hand. Okay, so you give me a bunch of cards. I'm going to take each card, add it to my internal card. We use this copy constructor. It's probably pointless, but we just did it for fun. Because cards are enumerable and can't be changed. For anything that could be changed, it's really a good habit to make those copies using some sort of copy constructor, that deep copy process. Because we don't want to have the same reference in case things change. Okay, and then we sorted it. That'll make sure now the default sort is low to high. And as long as we know that it's low to high, we'll be okay. We're in good shape. Okay? Then, so get hand ranks. Right? So let's pull up our different poker hand ranks, because I always forget all of them. Poker hands. Here we go. Okay, it'll be a little tight for a minute, but I think we'll be okay. Okay. So we did straight flush, four of a kind, full house, and then if is flush, turn ranked up flush. If is straight, no, it's straight. Return ranked out straight. If is three of a kind, turn ranked out three of a kind. We're getting there. Three of a kind. Gotta figure out how to type. Then if is two pair, turn ranked up two pair. If is pair, turn ranked up pair. And if you're not any one of those, right, the default case then is high card. Right? All right, cool. That's looking good so far. We need to add a bunch of methods. Right? So is straight. Now, again, all these are like just little helper methods. We don't need to have them be public at all, because we're only using these internally. So we're just going to make all these private, and then no one else has access to them. Okay. And it's two pair and is pair. I don't know what Spring Web Flux is. Sorry, Zabrick. All right, cool. So we got all of our methods there. Let me give it a quick little format. And they're upset with us because we haven't returned anything yet, but that's okay. We'll get there. But now our get hand rank looks pretty good. Okay. All right, so we're going to do some easy ones first, right? The get flush, or is flush, right? We said if the suit is the same as the other suit, right? And if the next ones match. So if card 0 matches card 1, and card 1 matches card 2, and card 2 matches card 3, and card 3 matches card 4. Right, so these are all ands together, right? If all of them match. 1, 2, and 3. And 2, 3, and 4. Right? Oh, why is it? There it goes. Oh, now the red lines went away. Oh, cool. Yeah, I've heard of Spring. I don't know particularly the WebFlux thing, but that's okay. I don't know everything. Right, so we're going to check the first card against the second card against the third card against the fourth card, and the fourth card against the fifth card. If all their suits match, we are returning true, because this will be true. If any one of them doesn't match, the whole thing is false, and we return false. Okay, how about a straight? A straight's pretty easy too, right? So we're going to return cards.get.0, get of 0, get face, ordinal. Oh my goodness. Get face. Ordinal. So remember, in order, like if we are 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, right? Each one is going to be one less than the one before it, right? So if the ordinal of 0 equals ordinal of the next one minus 1, and. Right, so if my ordinal is the same as the next card's ordinal, -1. And then if 1 is 2, 2 is 3, and 3 is 4. Right, same pattern. 1, 2, 3, and 2, 3, 4. And we don't need that trailing and. Okay? If you had to return an enum, well, that's fine. I'm just returning a true-false so that right in here I can just say, hey, if this is true, return this. Yep. So if it returns, it's like if you have like is straight flush and that returns an enum right away, we still have to return here, right? Or we have to return the result of this one, and that might not give us the right one. We just got to be careful which order we do it in, because the order matters a little bit. But it probably worked out okay. I'm assuming all of your code was tested and it worked for you. So okay, so is flush and is straight is done. How about is straight flush? Return is flush and is straight. Card 4 minus card 0 equals 4 for a straight. No, you can't do that one. You have to check every card because I could have 3 of the same face here in card 0, and then that 4th card over here at the end. So because we're sorted, you need to check every card in order because like one of them could be doubled up, one of them could be missing, that sort of thing. So just because you have a 3 and a 7 at the ends doesn't mean you have 4, 5, 6 in the middle. Well, no, so as soon as you return something, the method's done. Right? So there else is pointless here. It's redundant because if you return, the method stops. Right? So as soon as we hit a return, our rank is returned and we're done. It doesn't even evaluate anything else further in here. Okay, does this make sense so far for flush and straight? These are good questions. These are good. Okay, we're getting there. So actually the hardest one to find is 2-pair, weirdly. 3 of a kind, full house, 4 of a kind, and just a regular pair are relatively straightforward. Okay, you gotta do 4 of a kind first. Now, you might be tempted, and there's nothing wrong with this approach, to say, okay, well, I know I'm in sorted order, so card 1, 2, 3, and 4 need to be the same, or card 2, 3, 4, and 5 need to be the same face. That's a 4 of a kind. Yeah, that would work. Definitely works. Pretty straightforward here. That gets more difficult when we get to the full house, because then we're checking, well, is it 1 and 2 are the same, and then 3, 4, 5 are the same, or is it 1, 2, 3 are the same, or 4 and 5 are the same? And okay, that works okay. But then just a regular 3 of a kind, we're saying, is it 1, 2, 3, or is it 2, 3, 4, or is it 3, 4, 5 is the same? And that's doable. But then we get to pair, and is it 1 and 2 is the same, or is it 2 and 3 is the same, or 3 and 4 is the same, or 4 and 5 is the same? And that's feeling a little bit painful at that point, right, as we look at that. So I'm going to argue for a different approach. And what I'm going to do is I'm going to add a private integer array. And I always say I hate arrays, but this one is straightforward enough that it doesn't make me feel bad. This is count of faces. Oh, that's right, just a regular array. And then in the constructor, I'm going to say count of faces equals a new int array of size 13. Actually, I'm just going to put in a bunch of zeros. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is that it? Oof. Obnoxious to count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13. When you're sorting, set a bit mask for suit. Yes? Maybe? I'm sure something like that would work. All right, so if I have this count of faces, what I'm going to do here is I'm going to count every time I find each face here. So the number of times that I found a 2, the number of times that I found a 3, the number of times that I found a 4, the number of times I found a 5, on and on and on. Hey, awesome. Yeah, thanks for hanging out with us. Right, so I'm going to loop through. So I'm going to say for card in cards. Now, remember, all of those have ordinal values, and the first ordinal starts at 0. So I'm going to take my count of faces at the index of card.getFace.ordinal. So I'm going to get a 0 through 12, which will fit in this 13 size index. I'm going to take that value and add 1 to it. So if I've seen that face, so if I get a 3, it's going to find, okay, that's ordinal 1, it's going to increase that by 1. I found that face 1 time. If I find a 7, it'll increase that. No, I don't think it's in the book. I don't remember. I don't remember all of his examples. I feel like he did have card to like show enums, but I don't recall. Maybe it might be searchable. I can look and see. I mean, the rest of it's fine. Just having a card is no one's going to care. That's a pretty standard thing. All right, but this count of faces here, right, is going to tell me how many times each face showed up in my list of cards. Okay, so then when I come to 4 of a kind, I'm going to loop through. I'm going to say for int face count in count of faces. If my face count is equal to 4, return true. If I've gone through that entire list and I haven't returned a true, I'm going to return false. Give that a little format, clean that up. Right, so because I've already counted all of them, I just need to say, hey, did I find one that had a 4? Did any of those faces have a 4? Right? Okay. Now, I'm going to wait on full house here. I'm going to go to 3 of a kind. I'm going to do the same thing here, like this, but now I want to find count of 3. Now, at this point, you saw me copy-paste, and the only thing that was different was a number, was one thing. And hopefully you're thinking to yourself, hey, wait, you copy-pasted code, you should feel bad about yourself. Yes, that is correct. I did copy-paste code, and I do feel bad about myself. So, to make myself feel better, what I should do then instead is, what? Have a helper method. Right? You can have a helper method. So private boolean check for face x times. I don't know. Int what times? And if it equals the times, return a true. Right? So then I can just say return check for face x times. I want to find 3 times. Right? We're going to do that same loop as a helper method. So I'm going to check for a face as many times as you tell me. If it occurs that many times, great, we're going to return true. Do that. How about 4 of a kind then? So we'll check for face 4. For pair, we'll check for face 2. Oh, that's sorry. You have to return that value. Because it returns a value, we need to return a value. Return a value. Right? And then is 2 pair. Oh, I'm sorry. We didn't do full house. So full house is return is 3 of a kind and is 2 of a kind. I'm sorry, is pair. Right? If we're a 3 of a kind and a pair, we're a full house. Okay, 2 pair now. Now this one we have to do our own loop. Okay? We're going to loop through, and if it equals a 2, we found a pair, so we need an int for pair count. It starts off at 0. Right? We've counted 0 pairs to start. We're going to loop through. If we find a pair, and take our pair count plus plus. When we're done with our loop, we're going to return pair count equals 2. Right? Don't say if something is true, return true, else return false. If you're just comparing something, return that thing. Right? I think a lot of people would say if pair count equals 2, return true, else return false. Just return pair count equals 2, because this here is true or false. Okay? It's not so bad. How are we feeling so far? So this was the easy part, right? This is the hard part here, tie breaking. Okay? Everything else was the easy part. Is that fair? Tie breaking is the hard part. Because now we can just, if we're better or worse, sure, we're done. That works. Tie breaking our hands is hard. We'll switch over. Do we have any tests? I don't think we have any tests yet. Let's write some tests, right? I'm not going to write all the tests. Let me show you just a couple of them, and then I'm going to trust you could write the rest of them. As we had a chance, we talked in Discord for a little bit about what the tests might look like, and we talked about not all of these hand ranks can tie. So like some of them can only win or lose, right? So that's pretty easy. So a 4 of a kind will only ever beat another 4 of a kind or lose to another 4 of a kind. It can't tie another 4 of a kind. At least in this 5-card draw poker. It can when we do other poker variants, and that gets interesting, and we'll have to change our code later if we want to continue on and do other poker, right? But essentially, we can't tie in our game. Hey, wow, we got a whole big crew coming in. Trey Neal 3. Welcome on in, folks. We're doing our Java class, learning some poker. We're playing some poker. Nice. Welcome, guys. All right. So we're just about to write some unit tests for our poker hand class to make sure that we are properly tie breaking. So when one hand calls another hand, we want to make sure that we get the proper tie breaks. And again, we're assuming that we're just playing with a single deck, so you can't get a lot of these actually to tie. 4 of a kind can't tie, full house can't tie, 3 of a kind can't tie. I guess the other ones can all tie. Oh, Mainframe, thank you so much. All of the Prime subscription money and ad money and everything from Twitch is going to the Student Scholarship Fund over at U of M Dearborn. So thank you so much for donating that. That's awesome. Welcome in, guys. Hope you were having fun earlier. What were you up to, Trey? All right, so let's do, we're going to try 4 of a kind to start with. 4 of a kind. I guess we could do straight flush. Right back at mainframe, Trey. That's awesome. That's cool, guys. Day trading stocks. All right. How are they doing today? All right, so I need to set up a hand. All right, so this is a little bit tedious. All right, we're going to arrange, then we're going to act, and then we're going to assert. They stonked. Yeah. You have some days you win some days you lose some. All right. So we need 2 hands, right? And to make a hand, we need to have a bunch of cards. We're going to make a bunch of cards. So this is player card 1 is a new card. And now if I want a 4 of a kind, right, I need to give myself a bunch of the 4 of a kind cards. So let's go with card dot base dot, I don't know, how about we go with 9? And then card dot suit dot spades. Right, and then we'll have a card 2, we'll have a card 3, a card 4, and a card 5. Okay, and we're going to give ourselves a 9 of every suit here. Spades, hearts, clubs, and diamonds. And then some other card. How about, I don't know, a 10 of spades. That one doesn't matter as much. Okay, so I'm going to have my hand, and then we're going to have the computer hand, or other hand. Oh, that should be player, right? Player card 1. And then other card 1. Other card 2. Other card 3. And other card 4. So let's give them a, how about they have 8s? We'll have a 4 of a kind of 8s, right? And sure, another 10, that doesn't matter. Now we need to make the poker hands. So player hand, a poker hand, player hand equals a new poker hand. And we have to give it a list of cards, right? It wants a list here, an array list of cards. All right, so we need to make an array list and add all of those to it. All right. This is why once we do it once, though, we can copy paste and it won't be so bad. So we're going to make a array list of type card called player cards. The new array list of card. Here we go. Here we go. Yeah, we can skip all of this. So now we can just take player cards. Player cards.add. Player cards.add if we can spell right. And then we'll add all this stuff here. We'll cut all that out. Equals new card. Okay. And we'll do that 5 times there. We can just add the cards directly. We don't need to create them individually. Spades, hearts, clubs, and diamonds. Hey, you're up on GME? Nice. I'm in the hold gang. I'm down a little ways, but that's okay. All right, and then we'll make another array list of type card for other cards. There's a new array list of type cards. Right, and then we'll add in to the other cards list. There we go. We're getting there. We're almost ready to test. And again, let's do 8s or something. All right, well, welcome on in. And again, sure, we can leave that as a, that should be a 9 of spades. That should be like a 10 of spades, right? 10, it can be a 9 in our hand, it doesn't matter, 10. All right, so our hand then gets the first array of cards. And then the other hand is a new poker hand, given the other cards. Okay, so now we made 2 hands. Now we actually get to act. Oh, we're almost done, almost done. So we're going to have a poker hand dot rank as our expected rank. And that's going to be our poker hand dot rank dot 4 of a kind. Right, because we can test these ranks as we're also testing if they win, lose, or draw at the same time. Kind of take advantage of some of that. So when we're done, we need to get the hand. So we have a poker hand actual rank is my player hand, and I can use either one. They both should be 4 of a kinds. Player hand dot get hand rank. Okay, and then we can assert that those are equal. Assert equal the expected rank and the actual rank. Okay, that's part 1, and we're also going to then check to see which ones win, lose, or draw. So my hand, the 9s versus the 8s should win. Oh yeah, 2-dimensional arrays are lots of fun. So we're going to take a poker hand dot result, and then this will be the expected poker hand dot result expected win equals a poker hand dot result dot win. Right, and we can also do a win and a lose at the same time, because my hand versus their hand will win, their hand versus my hand will lose. Right, so we can check both. So this is an actual win is player hand, player hand dot call, and we're going to call the other hand. So when we have a 4 of a kind of 9s versus the 4 of a kind of 8s, we expect to win. And if we flip that around, we have an actual lose result if the other hand calls the player hand. Right, that should lose. So we can assert the win, lose, and lose at the same time, just to save a little time. So expected win and actual win, and then one last expected lose and actual lose. Okay, now again, this isn't going to work yet because we haven't done the tie breaks. nested arrays are the reason you ended up in software quality assurance. Hey, quality assurance is fantastic. You've got to be a talented person to be good at quality assurance. So if we run our test, right, we expect it to fail because we don't know how to tie break yet. If the only thing we have in poker hand is either you win, you lose, or you lose on tie breaks right now. So some of them might actually work, but the whole test is going to fail because not all three are going to work. Oh, compiled with errors. Actual, I don't know how to spell. There we go. Now maybe we can test our file. No, for real, that was not a smirk. Not a smirk. Legit, you gotta be really good to be a software quality assurance person. I love our QA folks. All right, so get hand rank. It says it passes because it didn't fail. So you do gotta be careful with tests, right? They should fail first. Can't invoke. Uh-oh. We're getting a null pointer exception. So it actually crashed here at poker hand line 15. Oh man, so I've told you guys about this before and I fell for it myself. The constructor's job, right, is to create instances of all of its variables. Cards never got initialized. I declared cards here. I'm going to say cards equals a new array list of type card. And we can size it at 5 if you want. Sure, it might make it ever so slightly faster. Okay, that should get rid of that null pointer exception. Let's try that again. So let's run our tests. This is good. Our tests are finding things already. Can't invoke sort because list is null in collection sort. Oh, that was it. In it here. Okay. Cards is this cards. This dot cards is this one here in purple. So why we write tests, right? Let's try it again. All right, now we expected to win, but we actually got to lose. All right. Here at, we expected to win, we got to lose. All right. Ooh, binary trees. I'm going to teach that class next semester. We're going to talk about data structures. That'll be a lot of fun. All right. So again, here's one for 4 of a kind here, and then we also might want to do then a straight flush. So let's do straight flush. Okay, so a similar idea. We're going to expect a straight flush. Now this one we can win and lose, but we're also going to have a tie as well. So I'm going to make one first. So we want a 9. Let's do all spades, I guess. Spades. More spades. So let's go with 9, 10, Jack, Queen, and King. Here. Okay, and the other hand that we want to beat then, let's go a little bit lower. So let's go 8, 9, 10, Jack, and Queen. Okay, and let's make them be, say, all hearts. We'll put all the hearts in here. Okay, so my hand should beat their hand, and their hand should lose to my hand. And we should be a straight flush. So that's that one. But then we can also tie as a straight flush. Yeah, if you do exclam class, it'll give you a little more info there. So I don't have all my bot commands put in the title or anything like that yet. Should figure out how to do that. So this is 4 of a kind ties then. Right, so if then we are the same, so we want... Oh, did I copy the wrong one? Yeah, I copied the wrong one. Hang on, I want the 4 of a kind. I want this one. I want a straight flush. Yeah, thanks. Thanks for using that command. All right, so if we want to tie then, if we're both the same, so let's add a king in here. And we're the same, so we have the same faces, but different suits, right? It's possible to tie. So our result should then be expected, we'll call it tie, I guess. Should be a tie. I think we called it draw, right? A draw. There, expected draw. We should do that. We'll have an actual draw. result. And we can assert that our actual draw is the expected draw. So there's no lose condition here, right? We could do it both directions, but I feel okay that this is going to be the same thing, right? We're not going to get a different result going either direction. We'll call this one draw. All right, so let's run these ones. Oh dear, where's my error? Test call straight flush. Oh, did I name that one draw? I must not have named it draw. I thought I named it draw. Oh, I changed 4 of a kind. That's why. All right, I'm getting myself confused here. Sorry, folks. Let's try that again now. Let's test it. All right, so good. So they're failing, which is good. We want them to fail because we haven't actually written the code to make these things work yet. Right? So I'm not even going to bother with get hand ranks because I'm just going to do those in all of our tiebreak tests. Right? Now we probably do want one though here. Let's where one hand type beats another hand type. Yeah, Java's pretty good. So it'll say like 4 of a kind beats full house. Sure. So let's give someone a 4 of a kind. 9, 9, 9, 9, and a king. Sure. So spades, hearts, clubs, diamonds. All right, should beat then a hand of a full house. So a king, 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 queen, queen. So that's a good full house here. So spades, hearts, clubs, hearts, and diamonds. Sure, why not? Okay. Oh no, they have the king of spades. So let's make that king of diamonds. Not that it actually matters, but sure. Yeah, web development's good stuff too. So then I don't care what the rank is here, and we expect a win result when we play their hand. We'll win. We call their hand. We don't need the rank. We just want to make sure that one rank will beat another, right? Actual win and expected win. Expected win. Okay, so this one should work, right? Because we can figure out hand ranks right now. We just haven't figured out our tie breaks yet. So 4 of a kind should beat the full house. And that one passes, right? And we don't need to do every combination because in terms of getting code coverage, right, all we know, right, the only thing we're testing here is that if our hand is better, we win. I guess I should have one where we lose. All right, now I'm feeling bad. All right, we can also then, we'll add in the lose here then. We'll do the actual lose. There we go. Oops, that's the actual lose. That should be an expected lose. Where'd it go? Right in here, right? Expected lose. Then we can assert that those are equal. Because then we're checking both directions. Okay. And where's our lose here? Because I want to make sure, right, that idea of 100% code coverage is saying that every line of code will run while I'm testing. So if I come to poker hand, I want to make sure that this line of code runs where I return a win. I want to make sure that this line of code runs where I return a lose. I want to make sure that all of my tiebreak stuff runs. I mean, we haven't built the tiebreak stuff yet, but we do want to test every rank, right? Because every rank is going to tiebreak just a little bit differently. Okay, we're getting there. Okay, so let's make sure that one still passes. Okay, we should win and we should lose the other direction. Win one way, lose the other way. All right, so 4 of a kind beats full house. Good. It will win or it will lose as we expect. So we feel pretty good here. We're getting some good code coverage off of this test. All right, should we go back and finish poker hand then and finish out those tie breaks? Now remember, tie breaks were a little bit tricky because they tie break differently. All right, so before we figure out what we need to do, we need to check. Okay, so we can go top down, right? A straight flush. Well, a straight flush, right? If we know it's a straight, then whoever's card is higher is going to win. Right? That's the same for flushes, and it's the same for straights. Okay, whoever has the higher card, because we know they're in order, whoever has the highest first card wins, or the highest last card wins. We can check. So if get hand rank is equal to a straight flush, or no, I'm sorry, yeah, rank dot straight flush, or get hand rank is equal to rank dot straight. Right? If we're either one, and I don't need to check the other rank because I know if we weren't the same rank, we would have already won or lost, right? So I'm only checking my hand rank as straight flush or straight because that's the condition. That means the other one must be as well. So here then I can say if my cards dot get 0 dot get face dot ordinal is greater than the other hand dot cards dot get face dot ordinal. If my card is greater, and I know we're in sorted order, then I can return a result.win. Else if oh yeah, sure. Let's do greater than, we'll do less than. If it's less than, I lose. Return result.lose. And if we're a straight or a straight flush and we didn't win and we didn't lose, we must have tied. Return. Yeah, actually, okay, so that doesn't even need to be an else, right? If we didn't return a win, check this one. If we didn't return a win, sure. Result.draw. We draw. It's for straight and straight flush. Right? Because we know the cards are in sorted order, so just check. If the first card is higher, I'm a better straight. We can check the last card. It doesn't really matter. You can check either one. I think most people usually check the high card just because, but that's okay. Both ways will work for you. Okay, so then we did the tiebreak for straight and straight flush. Yep, straight and straight flush. We could do 4 of a kind, right? Those ones will either win or lose. Full houses will either win or lose. 3 of a kinds will either win or lose. Because we know we have the 3 of a kind, they can't. Right? At least in this version. We can come back and change this later when we do other interesting poker variants. Okay, so let's do 4 of a kind then, I guess. Right, so if get hand rank is equal to rank.4 of a kind. Right, well now what I need to do is I need to find which face value had the 4 of a kind. So my little helper method down here, right, it just told me yes or no. What I really want now is what face value is it? So I'm going to do pretty much this exact same thing here. So get index of, I'm going to get index for face x times. And now I can't loop through this way. Right, I need to do a regular for loop here. So for int index is 0, index is less than, we know it's 13, or I could go by the length. It's probably better, right? Face counts, count of faces dot length. It's always more proper, right, to use that. Index plus plus. Now we're going to check, so it's no longer face count now, it's count of faces at index. And if it is true, I'm going to return the index. If it doesn't work, if I've gotten through that entire loop and I haven't returned the index, so let's return an int here, then I need to return, I'm just going to put -1, some awkward value that I don't expect to have. Okay, I've got too many, there we go, the for loop needed our curly brace. Right, so I can get the index for face that shows up x times. So however many times I'm looking for, I'll get the index value back. Right, so it was either at index 0, index 1, which is essentially the face ordinal. Right, we know that the index is kind of a substitute for the face ordinal. Okay. So let's see. So if we are 4 of a kind, I want to get my hand rank here. So this is int my 4 of a kind ordinal is the get index for face 4 times. And I know I have 4 because I'm only doing this in 4 of a kind. And I'll have another 4 of a kind ordinal is now the other hand dot get index for face. That shows up 4 times. Right? Because it's a method, I can use it on the other hand, because other hand is a poker hand. So I can use the same code on their hand as I'm using on my hand, but mine will give me my index, theirs will give me their index. I think we can just do a quick check. So if my 4 of a kind is greater than other 4 of a kind, return result.win, I'm greater, else return result.lose. Right? And there's no draws here. We can't have the same one, essentially. And other poker variants we'll come back to it later. But, right, get our ordinals. And then if mine's better, I win. If I didn't win, I must have lost, because there's no ties. I guess we could put in a tie if we wanted to, right? It wouldn't hurt to put in a tie. Right? Sure, we could do that. I'm feeling bad not putting it in now. If it's less than, we lose. Otherwise, we return result.draw. Okay, I broke it. Did I do too many curly braces all of a sudden? It broke everything on me. That was fun. Hydration. Thank you so much, Snake. You're right. I'm feeling a little underhydrated here. What did I do? I broke it. Oh, yep, there's too many curly braces. Yep, it ended the class here. That was crazy. So that's the call method. Yeah, call. Here's then, okay. Nope, that needs to be inside of, there we go. Inside of, for 4 of a kind, and a posture check, thank you. I am slouching a little bit here. Let me get my fancy backboard. You guys can see when I start disappearing off camera there, right? Like, slouch, 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 slouch. Okay, now this exact same thing happens again. Oh, a dad joke. I got a really good one for you guys. I thought you would like. So I was hearing about they were interviewing the new Attorney General candidate or something like that. Was it Merrick Garland? I think. Oh, awesome, Snake. That's cool. Yeah, so they're interviewing this new Attorney General guy, Merrick Garland, and someone had asked him about some weird thing in his history, and apparently when I forget where he was in charge of some district attorney's office a while back, he tried to hire a banana to be his lead prosecutor, and they said, well, why would you hire a banana? That's nonsense. And he said, well, no, I mean the banana is a really good prosecutor. He always causes the defense to slip up on appeal. You know, I would actually love it if someone would tell a dad joke like in one of those Senate confirmation hearings. That would just be amazing. Those guys take themselves way too seriously. Okay, so we're going to do essentially the same thing here now if we are a 3 of a kind. Or if we are a full house, right? Because a full house has a 3 of a kind in it. Full house. Okay? Slip up on appeal. Yep, appeal. All right, but now we're just checking for the index of the face 3 times. Either we win, we lose, or I guess sure we could draw, but not really. Okay, so we've done, let's see, we took care of straight flushes, we did 4 of a kind. Did we do 4 of a kind tie breaks? Yeah, we did 4 of a kind, so we did straight flush. 4 of a kind, we did full house. We haven't done flush yet. So flush actually tie breaks the same way as the high card does. Okay? Right? Because as we just look at the top card, and we look at the next top card, and the next top card, and the next top card, and the next top card, we have to look at all 5 in a row here for that one. So I think we're missing 1 pair and 2 pair. And now 2 pair is actually hard. So we need to do 2 pair first. Because remember, our hands are pairs technically. I guess no, our get hand rank will always return a 2 pair, but we can do that. So let's do 2 pair next, I guess then. So if get hand rank equals rank.2 pair, Now we have this helper method here, but this one only gets us the lower index. Oh, I should rename that here too. This is my 3 of a kind. Three of a kind ordinal. There we go. Man, that's a lot of copy pasting I had to do for that. That's silly. Okay. Just to make that cleaner. So this is my pair. And this is actually the lower pair ordinal. And I know that it's lower because we start at index 0. Right? And we go on up. So we're starting with 2, going up to 3, 4, 5, 6, 7, all the way up. Excuse me. So I need a way then to get the higher pair ordinal, because we need to check the higher pairs. If the higher pairs match, then we check the lower pairs. If the lower pairs match, we check the 5th card. Right? Oh man. We can do it. We can do it though. Okay? So we need a way to get the higher ordinal. So this is get index for higher pair. Right? We'll make a helper method. That's all we need. Like, you don't have to tell me anything. I just know it's going to be a higher pair. So I'm going to go the other direction. I'm going to go starting at length. And I'm going to go as long as I'm greater than or equal to 0. Right? Just reverse it here. Greater than or equal to 0. Index minus minus. And if it equals 2, right, because I know this one's for pairs, here, return that index. Okay, so we can get the index for the higher pair. Okay, so I'm going to do the same thing here then with the higher pair. My higher pair and other higher pair is get index for higher pair. Right, and it's a helper method, so I can use it on their class as well. Their poker hand, which is fantastic. All of our code gets to do double duty, my hand and their hand. And now we say we need to compare. So if the other, my higher pair ordinal is greater than their higher pair ordinal, we win. Return result.win. If my higher pair ordinal is less than their higher pair ordinal, right, make sure we do a less than there, right? They win. So we lose, result.lose. Okay? If they're not greater than and less than, that means they're the same, right? Now I need to check the second pair. So my lower pair ordinal versus their lower pair ordinal. Right? If that one doesn't win or lose, well, then I have to check the 5th card. I don't know which one is the 5th card. Right? But I know at this point, I can check every card from high to low. Right? We can say for index 0. Oh, I actually want to start at 5. Cards.length, sure. Cards.size. Yep. Index is greater than or equal to 0. Index minus minus. Start at the top, work our way down. Because I don't know where order the pairs are in, but I know if my 2 pairs are high and their 2 pairs are high, they'll be the same. And then if they have a middle card, if their 3rd card is something different than my 3rd card, because our lower pairs are the 4th and 5th card, sure, we're fine. Okay, so we're going to loop through. We're going to say if cards.get, nope, cards.get at index dot get face dot ordinal. All right, so if my ordinal there is greater than the other's ordinal, other.cards.other hand, there we go, .cards.get, oh my goodness, that is a long line there. All right, I'm zoomed in a lot though, so you know that it's there, right? I'm feeling bad it's so wide. We win. Result.win. Okay. If we didn't win, let's check to see if we lose. So if we are less than, oof, man, turn result.lose. Feeling really bad about how wide that is. One return. So in general terms, is it better practice to do one return and an if else nested or multiple if with multiple returns? I prefer to see the returns. I used to think multiple returns was ugly, but I've really come around to it, and I think it works out cleaner most of the time. And it's ever so slightly more efficient, because if you return, you're done. Right? Otherwise, you have to keep evaluating the next other conditions. So it's ever so slightly faster. I think is why I'm partial to it. So if we do this entire loop here, and we haven't won and we haven't lost, well, we must have drawn. Result draw. Right? Because it means all 5 of our cards then are the same face ordinal, which is possible, right? We could each have 2 pair, the same pair, and then we could each have the same 5th card. It's not going to cause a problem. Okay? So that's 2 pair. 2 pair is a pain to tiebreak. Look at that. Like, a bunch of lines of code for the tiebreak here. But what's nice, though, is actually I can take all of this here, and I'm going to right-click and say I want to refactor. I'm going to introduce a method. This is tiebreak all 5 cards. Okay, and it's going to add a method for me for tiebreak all 5 cards that will return those results. Because this is the way that we tiebreak for flushes and for high cards. Right? So we can say if get hand rank is equal to a flush, rank.flush, we can just return the tiebreak this way. Tiebreak all 5 cards. Boom. Done with that one. Right? And then if we haven't already done it, right, we know we must be, like our default case, we haven't tie-breaked already. Is that must be a high card? Now I am missing pair, right? So I do need to look for pair in here. So I'm going to move this up. I don't know if it matters. Well, sure. 2 pair. We'll tie-break pair. If get hand rank is equal to rank.pair. Now pair was easy to tie-break, right? We just did this ordinal thing. But now, hopefully you're feeling bad, right? Because this code is the exact same as this code here, right? So I don't even need to get index. I just need to tie break on index. So I'm going to change this whole thing up, right? Let's extract all of that. So I'm going to go to refactor, introduce a method is tie break on base index x times. Oh no, okay, never mind. It's not the exact same thing. I'm sorry. So 4 of a kinds and 3 of a kinds can't tie. Pairs can tie. That's right. But we can do the same thing here. We can still get our ordinals. Okay. So my pair ordinal and other pair ordinal. Okay, and we can check if they're the same or not. So it's my pair ordinal and other pair ordinal. We win or we lose. And if we didn't win or lose, right, well then we need to tie break all 5 cards. Oh shoot, I broke it. Nope, I missed my curly brace. Format, there we go. Okay, there. I think I fixed it. That's terrible. All right, so if we're a pair, check it. We either win or lose based on our pair. If not, we have to check all 5 cards. See who has the next highest card, the next highest card, the next highest card. Right? So I think that's all the ranks here. So I'm going to move this up just so it's closer to the other ones here. Right? So we're kind of in order. And they're not exactly in order because we like do 3 of a kind and full house in here. 4 of a kind. Get straight. Get flush. Well, how about we do it after 4 of a kind, maybe? Sure, why not? Throw it in here somewhere. And I think we've got them all. Right, so let's try our tests. See if our tests work. We did straight flush, 4 of a kind. I know we didn't do all the tests. Hopefully you guys did all the tests because that's how you get your points. But look, now our tests pass. Feel pretty good about most of these. Again, I would write the tests to make sure I'm testing all of them here, because some of these were tricky. But how's that feel? You guys feeling okay so far? Our unit tests. Our unit tests. All right, awesome. Awesome. Okay. So that's pretty good. So now we have to go and actually make the game part. Right? That was just what we needed to do so we could play a game. So we have our deck with our list of cards, we have our enums, we have the copy constructor, we can get a random card out, we can get 5 cards from the computer player, 5 cards from the user player. Now we're going to bet $1 initially for each of them. They're going to raise, the computer's going to fold half the time. So we have to figure out how we do this raising thing, and then we compare the hands to see who wins. We did the poker hand with the private attributes, win, lose, draw, enum. Yep, doing the tie breaks. Keep them playing until they quit or run out of money. We can just, until they run out of money is fine. I don't actually think that made it into the rubric here. Right? Oh no, it does say until they quit, so sure. Maybe we'll give them an option to quit. Right? So we need a couple things then. Right? We need random. We need random for the computer to decide whether or not they want to fold. Right? We need an int for player money. And I'll start off with like $100 and an int for computer money. Start them off with $100. We need array lists of cards. We can do that in a minute because we need a bunch of cards. Let's see, what else do we need? Oh, we need a way to print these things, right? So that we can output what their hand is. Right? When I just make a poker hand, it's not going to work very pretty right now. So let's say we'll do while player money is greater than 0 and computer money is greater than 0. We can keep on playing. Right? Once you run out of money, you lose. Game over. Okay, so let's deal some hands. So we'll make an array list of type card for player cards. The new array list of type card. And we'll have one for computer cards. All right, so inside the loop, right? So this is every hand then. Make a new array list, make a deck, equals a new deck. And now for int card number 0, card number is less than 5, card number plus plus. We'll just do a little loop here, and we'll take player cards dot add, and we're going to add deck dot get random card. And we'll take computer cards, and we're going to add deck dot get random card. So we'll draw random cards for the computer and the player 5 times. Okay, then we can make hands. So we have a player hand, or poker hand for player hand. Here's a new poker hand, given the player cards. Right, and a poker hand, computer hand. Here's a new poker hand, given the computer cards. Right? So now we have hands. Great. We probably want to tell the player what their hand is. Right? So we can just print out the player hand. And then ask them, do they want to call or raise? Raise $1. So we're going to need some input here. We need a scanner. Right? Scanner keyboard, the new scanner. Given system.in. Okay, then we can ask them. So we have a string for, I don't know, choice, keyboard.nextLine, and then if choice was choice.equals ignore case, if it equals raise, ignoring case, raise, then we'll take another $1 out, right? So we need to take dollars out of their hands, right, every time we loop. So we'll deal them cards, take player money, minus, computer money, minus minus. Oh, we'll have this. We'll probably need an int for pot somewhere in here, right? Computer money. Computer money minus minus. There we go. Okay, so we set the pot at 2. If they do raise, then great. So then the player money minus minus and pot plus plus. And now we need to flip a coin, right? Do a random thing to say whether or not the computer wants to call them or not. Okay, so we'll say if random.nextInt, and if I go from up to 2, I'm going to get 0 or 1, right? So if nextInt 2 equals, we'll say a 0, we'll print computer holds. So then the player money plus equals the pot, right? They get the pot and they win. Right, computer folded. That was it. So at that point then, I'm actually going to go with that ugly continue that I said probably don't use. So continue our loop, right? But we'll jump back to the loop header, right? Otherwise, because this is going to make this a little cleaner, right? So if we raised, great. If not, then that means the computer calls. So then the pot plus plus and the computer money minus minus, we'll say the computer calls. Your calls, your raise. Okay, and then we're just going to keep on going. So then we can actually find out, well, now let's compare the hands. Right, so then we'll just print out the computer hand. Hey, Crow, thanks for coming on by. And we'll add in here the computer hand. So we should probably say what our player hand is, right? So player hand, or your hand, right? Okay. So if they did call, right? If we didn't raise, we just called, right? So we still get to the call position here, right? We each bet $1. And see what the computer hand is, and then we're going to check who wins. So if player hand dot call, call the computer hand equals, right? So we're going to see which result this is, right? If it equals a poker hand dot result dot win, means we win, right? What's going on with all these curly braces? There. So if we win, player wins. And then we'll take our player money plus equals the pot. If we didn't win, well, let's see, else if maybe we drew or we lost. Lose. The player loses. And then the computer gets the pot. Computer money gets the pot. Right? And if we didn't win and we didn't lose, we must have drawn. Not that, else. Draw. And then we each get half the pot. So computer money plus equals pot divided by 2. And player money plus equals the pot divided by 2. Computer money. Right, we each get half the pot. Okay, we just keep on going. So maybe we want to print out how much money we have there too, right? So we could print out how much money we have. Player money. Player money. And we can do the same with computer money, right? Why not? Let's do another line. So let's just start the hand. Oh, maybe we'll do that at the end. I don't know. Should we do it at the end of the round or beginning of the round? We'll do the beginning of the round. Why not? Okay. So let's just keep on going. So if we run this guy, we get poker hand at, ooh, that's gross. I don't know what it is. Right? So we need a 2-string in poker hand. Right? Well, poker hand needs to turn cards into strings. So card needs a 2-string first. So we're going to add an override for public string toString. And this is going to return a string, right, of, we want what our base dot toString plus of plus suit dot toString, right? So like 2 of spades, right? 3 of hearts. Great, that one's not too bad. Poker hand, though, is a little bit trickier, right? So we'll come down, I don't know, private methods usually go at the bottom, public ones at the top. I don't really care where you put it too much. You got tools, I can sort it for you. Override, public string toString. So we're going to do this the right way here. We're going to use a string builder, right? Builder, the new string builder, because we talked about this before. And just doing a bunch of string concatenation is really, really slow. And we don't want to do that. We're going to take builder dot append. Nope, not builder dot append. Builder dot append. And let's do our get hand rank dot toString. Right? And then we'll builder dot append. How about, so make some space in here between those, so our hand rank. And then we want to say for card in cards, builder dot append card dot toString. And between the cards, we also need to put a space in, right? So card space, card space, card space, card space. Right, and when we're done, we return builder toString. We can use that string builder to make sure we're not doing all the string concatenation, and now we should get out some pretty strings for our hand. Here we go. We're a high card hand. We have 2 of diamonds, 9 of clubs, jack of spades, queen of hearts, ace of hearts. Oh, not a great hand. Let's just call. Oh no! Index out of bounds exception. Tiebreak all 5 cards. Oh, yeah, we can't start at size. We have to start at size -1. There is no index 5 when we have 5 cards. All right, that was good. We found out. Let's try it again. All right, high card again. 3 of clubs, 4 of diamonds, 7 of clubs, 10 of clubs, king of spades. Let's call. The computer's hand was also a high card. We won, because their high card looks like a jack, and we had a king. So now we have 100, they have 98. All right, our next hand here is a pair. Ooh, we have a pair. Let's raise. All right, the computer folds. Let's just raise. We just need to bully the computer here. Raise, raise, raise. Keep getting high card hands. We got a pair. We got a 2 pair in there. Oh, the computer had a 2 pair, so we lose. That's all right. Raise, raise. A 2 pair, a high card, a 2 pair, high card. Let's see if we can get anything more interesting than that, right? Pair, high card, raise, raise. A pair, more pairs, high cards. I want a better hand. Here, I should just copy paste because I keep typing that and that's silly. 2 pair, high card, pair, high card, high card. Full house, there we go. Look at that, we got a full, oh, the computer got a full house, ouch. They beat our high card for sure. 3 of spades, 3 of clubs, 3 of hearts, 10 of clubs, 10 of diamonds. All right, but we're still making money because we can bully them. All right, how's everybody feeling so far? I think we've got all of our objectives here then, right? Oh, we don't have until they quit. Sure, we could ask if they want to quit. Okay. I think that's it. Thoughts, questions, concerns? It might be a little bit different than yours. That's okay. It's not a problem if it's a little bit different. Nothing says it has to be the same. As long as it gets the job done. Let me open up my GitHub. I'll commit this to GitHub. All right. 2151. There we go. So here's a bunch of new stuff. So all the tests was new. All these other ones were modified, right? This is project 2 complete. Commit. And push. I remember you can always go get the code out of GitHub. It's !GitHub there in chat for the link, or if you can go find it in D2L. We've got it out there as well. All right. Oh, we've not taken a break yet. Oh my goodness. Yeah, dealing 5 cards each turn. Yep, there's just 5-card stud. And we're with forced raises. Yep, so we just deal in 5 cards, and then we see the computer's dumb and will fold sometimes, just for fun. Yep. I guess we could do 5-card draw next time, right? See if you want to trade in any of your cards, right? Although it'd be hard to tell the computer, make the computer draw cards. I don't know if we'd have a good way of having it do that. That sounds tricky to figure out, like making the computer smart enough to draw cards if it needs to, and which cards to draw. There's probably some easy rules we could follow. Just draw a random number. Poker machine learning algorithm. Yeah. That's doable, right? We just train it to see which hand is better, what wins more often. Model out the hand that it has. Yeah, blackjack. Blackjack is easier if you want the dealer to draw. We'll do that in my Python class this semester. We're going to do blackjack. That's usually a lot of fun. But they have to build an odds calculator. And then they build out a strategy guide that allows them to count cards and see if they can do better than the regular odds. A hat. Yes, you got it, my friend. I've got my awesome chess bra hat here. The OG of chess streamers. There we go. Yeah, I've got all sorts of streamers, Twitch swag from some streamers, so it's good times. All right, we haven't taken a break yet, and we're almost out of time, actually. Yeah, thanks, Snake. So I think we might just call it a day then and actually not get to anything new in Chapter 10, because we still have Thursday to talk about Chapter 10. And it's getting late on the clock. Like, if we took a 10-minute break now, we'd have, what, 10 more minutes to chat after we got back? 11:50. I guess we'd have 15 minutes to... Oh, let's put it to a vote. I will allow you guys to vote if we should be done or take a break and come back. Done, break, or continue. Continue. You can end now, or we can 10-minute break and then continue. All right, so go ahead and vote there in Twitch chat. All right, go ahead and vote. Troy. Yeah, I think it pushed to GitHub. It should be there now. Let me see. Repository, view on GitHub. While you guys vote for whether or not we should just be done now or take a 10-minute break and come back for 10 some more minutes. Let's see. There we go. We should have project 2 with all the good stuff in here. Yep. We did 3 minutes ago. Looks like it's all there. All right, go ahead and vote for me. Oh, of course, I messed up. I moved the stream manager. Now it freaked it out. I'll be working on grading those this week and maybe even over break. Hopefully I can get them done by Thursday. Might be a stretch, but this week I'm going to be working on them. All right, I got 8 votes for we should end now, 2 votes for a 10-minute break. So I think we'll just call it done for today. We'll come back to Chapter 10 on Thursday. Don't forget, I do have office hours today, 1 to 3. Tomorrow, 1 to 3. And then Thursday, just a little bit before my evening class, 5:30 to 6. If you want to chat. If those times don't work for you, shoot me an email, find me on Discord. Let me know a good time for you, and I'll see if I can make it work. Okay? All right, I think we're all set then. Should we go find someone else to bother? And send a raid off their way. Let's see who's around. See if anyone's around. Let's see. I think we can go find Gath. We can go learn some chemistry. She's not teaching her course at the moment, so I think we're free to raid. No, raids are turned off still. Okay, that's a bummer. Maybe more psychology? That's interesting stuff too. And the psych and soft skills are super good. Or do you want to do chess? Should we do psychology or chess? Yeah, thanks for coming on by, Trey. Appreciate it. Ooh, we could do C# Fritz. Oh, let's do C# Fritz. Let's learn some C#. Sorry, we're not doing chess either. Or Psych. Oh no. It's Psych Queen. Is her channel if you want to go check her out. But we're gonna go raid C# Fritz. He's a great guy. You guys have fun. I will see you next week. Or no, on Thursday. I know what day it is. I'll see you.